Hello viewers, I am Mrs.M.Govindammal, Assistant Professor of Computer Applications, SFR College for Women, Sivahasi. Today I am going to discuss about queue representation and its operations. In this video, we learn queue can be implemented using arrays. Queue can be implemented either using arrays or linked list. The insertion is possible in the one end, that is known as rear, and the deletion is possible in the another end, that is known as front. While implementing a queue, you can take care of FIFO rule, that means first in, first out. Now the definition of queue. A queue is a linear data structure that follows the first in, first out principle. In this above example, like a line at a ticket counter where the first person to join in the line is the first to be served. Now let us see the basic operations on queue. Some of the basic operations for queue in data structures are NQ. This operation is used to insertion of elements to the queue. DQ. This operation is used to removal of elements from the queue. Peek or front. This operation is used to accuse the data element available at the front node of the queue without deleting it. Rear operation. This operation is used to return the element at the rear end without removing it. Is full function. This is used to validate if the queue is full or not. Is empty function, which is used to check if the queue is empty or not. The size operation is used to return the size of the queue, that is total number of elements it contains. Now let us see the first operation, NQ. The NQ operation is used to insert an element at the end of the queue, that is at the rear end. The following steps should be taken to NQ data into the queue. First, check if the queue is full or not. If the queue is full, return overflow error and exit. If the queue is not full, it increment the rear pointer to point to the next empty space. Then add the data element to the queue location where the rear is pointing. Finally, it will return success. The element 5 is inserted into the rear. Now let us see the second operation, DQ. The DQ operation is used to remove and return an element that is at the front end of the queue. The following steps are taken to perform the DQ operation. First, check if the queue is empty or not. If the queue is empty, return the underflow error and exit. If the queue is not empty, it accesses the data where the front is pointing. Then increment the front pointer to point to the next available data element. Finally, it will return success. The element 40 is deleted from the front. Now let us see the front operation. The front operation is used to return the element at the front and without removing it. The following steps are taken to perform the front operation. In the above example, if the queue is empty, return the most maximum value, otherwise return the front value. Now let us see the rear operation. This operation returns the element at the rear end without removing it. In the above example, if the queue is empty, return the most minimum value, otherwise it will return the rear value. Now let us see is empty operation. This operation returns a boolean value that indicates whether the queue is empty or not. In this above example, check if the front value is equal to -1 or not. If yes, then return true means queue is empty, otherwise it will return false, queue is not empty. Now let us see is full operation. This operation returns a boolean value that indicates whether the queue is full or not. In the above example, check if the front value is equal to 0 and rear value to the capacity of queue. If yes, then return true, otherwise it will return false. Finally, the size operations. This size operation is used to return the size of the queue, that is the total number of elements it contains. In this example, we can receive 5 total number of elements in the queue. Thank you for watching this video. Thank you.